we're working with the Swift classes is the next thing we're going to be adding to this. And so a class in Swift is just like a class in Java. It's how we represent an object. So a class is a representation of an object. And in Swift, we have the same basic structure that we were looking at when we were learning how to do classes in Java as well. So we're going to go ahead and take a look at that. So we have first thing is the visibility. Swift calls it specifically the access control modifier. And so we'll start off with public, like normal, and then the name of the class. Scratch that. So public and then class, and name of class. There we go. Public class and then name of class. Followed by our great friends, the squigs. Boom. And so we have here the equivalent of stupid project number 1 in Java, where we have a public class with a name, followed by an open set of squiggles, closed set of squiggles, and nothing inside it. This class does absolutely nothing. But it looks just like a Java class, and the Swift class has the same basic structure to it for the framework itself. So it makes a class. This makes a name of class type thing. And so we have, again, we have the visibility for the class, which for us most of the time, 99-ish% public. The keyword class, always there, followed by the name of the class. And again, the name reflects what? What it's doing or what it is. What it is, what it does. That's an easy, quick way to remember. It's just a nice description of that. And again, we always use a capital letter to start the name of the class because it's a thing, it's a proper thing that we're dealing with. And we want to keep track of it when we're writing our code so we can differentiate between an instance and the actual class itself. So keeping those things in mind. The next thing we're going to have is, just like in Java, we have our data member section or declaration section. And inside our declaration sections, where we're going to put all of our class variables, the things we need to get access to for the entire class. And because we're using Swift, the structure for those class variables will be var, the variable name, and then because Swift is picky now, colon and type. And so we have a quick explanation as to what's going inside it. So it's a variable. Here's the variable name, and it's of type type. So we have an actual representation so we know what kind of thing is actually stored inside that variable. Now, because this is just like Java, it's pretty similar to that. These should, of course, be a visibility of private, because our visibility or access control of data members should always be private. We'll talk about some special circumstances that go along with that in a bit. But for right now, the basic rule applies that these are private just like the class is public in Java. So that same basic rule applies. We just have the difference with the var up here in front and the type at the end because it's Swift instead of at the beginning like Java. So a couple small changes, but similar in basic structure. Now, where we start seeing some actual differences in the way Swift works is the next section, which is the init. And so in Java, we have the constructor, what is used to actually build the object. And so it has the constructor has the same name as the class, which has the same name as the file, which is the same name as the type. In Swift, it's different. In Swift, instead, we have the initializer, or the init. And just like in Java, the init has a visibility. It does not have a return type afterwards. It is merely just the creation of that object. Now, here's where Swift really scores some points with Henriksen. In Java, if I were to create an object and I don't take care of the data members, when I initialize my object, I try and access anything on that, and if I don't initialize it, it's going to crash burn, my entire program will shut down. I'll get a null pointer exception. However, Swift prevents the null pointer exception because of non-initialized data members, because every data member must be initialized. Member. And then in big caps, double underscore, by the end of the init. So in this case, where we have private var variable name must be initialized before that closing squiggle. If we don't initialize variable name by the closing squiggle of our init, it won't even compile. So we can actually prevent many of the beginning errors of code by following good design principles because Swift enforces it inside the actual init structure. You can't have an uninitialized data member. When you have any data member that belongs to the instance of the class, any required information, all required information for that class type must be initialized inside the init at the very latest. So it says, oh, you have to exist? Oh, okay, I'll take care of that. If you don't have it initialized before that closing squiggle, it won't even compile. You can't even actually test your code. And so we'll be demoing that inside our class just like we did with Swift, we'll be demoing that with Swift just like we did with Java earlier. But since we have playgrounds, we can demo it out. Now, the standard rule applies just like with Java. In general terms, the name of the class right here is also the name of the file. But because we can also use the Swift Playgrounds tool, that name of the file can be skipped a bit. So name of the file, let's make sure we can read that. So the name of the class should be inside the name of the file. Swift, however, allows you, quote unquote, to name it something different. Don't. Just don't. The name of the class is the name of the file. Make life happy. Trust me. You will be happier with your code. In Playgrounds right now we have simply just content.swift, and it's just what is going for the playground. But as we do more advanced programming, aka next week, you really want to have your code in chunks that make sense so you can use them. And we'll see that happen in just a bit. So the name of class is the name of the file in regular Swift land, and unlike Java, not the name of the init. And then just like Java, methods we'd put inside here as well. Methods, like we looked at the other time, have that same structure where we have the visibility modifier. We have the func keyword, not funky. And then we have the name of method, followed by the parameter list, followed by the return type. And that'd be a capital V. And so we have that structure inside that would go inside here after the inits. And so a class is built just like Java is, where it has n data members, it has at least one init, and any data member that exists inside the class must be handled inside the init, and methods exist to be used inside the object as needed. And so we talked about how we can use that here in just a bit, but here's the basic structure of how that's going to go. Okay? Before we move on, any questions about that basic structure? Yes, Kashish?
So the public class, the public init is within the class?
Yeah, so this is within the class. Yeah, so this is inside these squiggles right here. This is indented inside. Yes. Yep, for sure. Good question. Anyone over here? Questions on this side? Okay, questions in the back? Thumbs up if you have a decent idea. Okay, double thumbs up if you have this in notes too. Wunderbar.